Okay, hi, my name's Elaine. I'll talk about bootstrapping and maintaining a Lightning node. And hopefully pretty much all of you have probably already set up a node, so this should all be review, and you guys will probably be able to, or you guys probably know more about this than I do. So we'll start with an overview of how routing works, just to understand what the nodes are trying to do, and from there we'll step back and look at ways of finding peers and getting incoming channels and maintaining capacity. And okay, so we'll start out with route formation. So in theory, so when you want to make a payment, you have to figure out how to get it there yourself, even if you're not directly connected to the recipient. In the Lightning Network, routing is source-based, which means it's up to the sender to figure out a working route. And the way of finding a route varies by implementation. Routing isn't specified. So it's still open-ended, and it's by no means a solved problem. The Lightning Network itself uses onion routing, so intermediate nodes only know who they should forward each packet to. They know the predecessor. They know about their predecessor and the successor, but they don't know the packet's origin or final destination. So the nodes along the way can't really help you out midstream. So I mean, this makes routing more flexible, and it's there to keep transactions private and give participants anonymity. Okay, so every node in the network has their local network view, and from there they have to figure out some number of best paths to try. And the path choice right now is the criteria that's taken into account by a payment sender is determined by the transaction fees or the payment fees along the way, and also they take into account the time lock that will be incurred. Because right now, every node that forwards a payment that helps to forward a payment from the sender to the recipient does incur a risk. That the node accepts the risk that the payment or the time locked payment it accepts will time out before before the payment before the time locked payment it forwards gets fulfilled at the endpoint. So because of that, every intermediate node will add some time lock delta to the next payment or a time lock payment that it forwards. So when a sender is determining the best route to take, they'll take into account both the time lock penalty, because they don't want to have a potential really long timeout wait period, and also the fees, because no one really wants to pay fees. Yeah.
Isn't there another consideration for having a longer path for privacy reasons, like not including all intermediate?
Oh, absolutely. I mean, right now this is just, it's a simplistic view, and it's how the implementations do it right now, but there are certainly better ways of doing it. But for now, the sender will basically do a best first search to find some number of paths to try. LND uses Dijkstra's algorithm, and I think C Lightning uses Spellman-Ford, which is similar, but can also take negative fees into account, because sometimes nodes will have a negative fee on their channel if they want to encourage more payments to get routed that way. Okay, so let's say node C wants to send something to node H, and it comes up with 3 different paths of increasing cost according to their cost function, which takes into account the fees and the time lock penalty. The different Lightning implementations are getting more consistent with error reporting. So maybe they try, or C tries the first route and discovers that the channel from F to H doesn't have a sufficient balance to forward the payment. So then it knows to skip the next path and then go straight to C, E, G, H. And ideally we have at least one path that works and the payment goes through. And in theory it works, but in practice we often get a lot of errors, and sometimes the payment failure feedback isn't really good, and then people complain, and concerned trolls will say Lightning doesn't work and routing won't work. So our goal here is to try to make it so this happens as infrequently as possible. All right. So that's what we're trying to do, and so based on that, we have to figure out how to make friends. And this is, we have choosing which nodes to form channels with will help us prevent that from happening. So when a node first, spins up a Lightning instance, it doesn't have any peers yet, so you need peers to get started and find out information about what the rest of the network looks like. There's currently a DNS seed server that indexes nodes and pulls out a random set of nodes for bootstrapping, and this is similar to the one that's used in Bitcoin. I think only LND uses the seed server right now. But it's also useful because if a node doesn't have a static IP address, it can go offline and come back, and this is a way to find the node again if its IP address has changed. Okay, so presumably a node knows about, a node can contact the seed server, find out about which other nodes are currently in the network, and then it has to open channels. I won't go too much into the details about how channel formation works. I think Chris did a good job of providing an overview of that. But basically, a channel is opened when the person funding the channel, in this case node A, sends an open channel request to node B. And the open channel request has a bunch of fields in it, like the funding amount, the push amount, which is the initial amount that goes to node B, and other stuff like the channel reserve, the delay it's willing to wait for a time lock payment. For the most part, node B can either accept the channel or reject it, and for the most part, there's not going to be a lot of disagreement between node A and node, or there's not going to be a lot of complaint from node B if node A wants to create a channel. In the early days, there was some difficulty in creating channels because there were different thresholds for what different Lightning implementations would accept for channel openings. But right now, I think most people just use the default settings, and that makes interoperability much easier. Okay, so let's assume node B responds and accepts the channel opening. There's going to be a revocation pace point from which we can derive, I guess, leverage to punish misbehaving nodes in this channel. Okay, so we have so node B accepts the channel, and this is, if you think of a if you think of a channel like a smart contract, then opening the channel is like the offer, and then if node B accepts, they're basically in a contract together. They agree that they're going to operate this channel, and so node A will create the funding transaction on chain, and the funding is then blocked. They both acknowledge it, and now they can use the channel. Yeah.
Previous slide.
Yeah.
Yeah. Are funding created and funding blocked are actually necessary? Is it enough to what's the blockchain? I mean, I want to understand like the rationale. Maybe I'm missing it.
I think you need to sign. Like, don't you need to sign? That way you can create it.
Ah, that's the signatures then?
Yeah.
Okay, okay.
Yeah, the funding isn't actually broadcast when when the transaction's created. They both need to say. Alright, okay, so we'll pretend that this is just a private channel between A and B. It's not forwarding payments for anyone else. So let's say Node A sends some update messages to add more time lock transactions. And they can commit the transactions with a signed commitment, and Node B will reply with a commitment preimage for the previous commitment, or Node B will revoke and acknowledge each new commitment. And basically every time a commitment is created, there's a public key that's created that is associated with the commitment. So if the commitment later becomes revoked because a newer commitment is created, then the person who has the private key for the revocation can claim the amount in the channel. So because the revocation key is created using the previous commitment and the revocation base point. So if Node A tries to broadcast an older commitment, then Node B can see that and derive the private key because it had the revocation secret and claim all the money for itself. On the other hand, Node A would have to wait for the delay that they initially agreed upon when creating the channel to try to spend the money. So this gives B some time to react, or it also, I mean, it does give B some time to react, but it also creates the encumbrance that Node A could have their money locked up if B disappears. And if Node B disappears, that actually becomes a liability for Node A because they probably opened up the channel with the intention of using it to make payments or using Node B as a routing point to send payments elsewhere. So an unresponsive Node B means that now this channel is stuck in limbo until for some amount of time, and it's kind of a pain in the butt for Node A. So, I mean, the point is, we want to be able to create channels and not run the risk that our counterparty in the channel disappears or misbehaves. So, I mean, one of the most, I guess, critical things in finding a good counterparty to open a channel with is that they're going to be online, because a node that goes offline renders the channel not very usable. And aside from that, we also want nodes that will maximize connectivity to the network, because every time a channel is opened, that's some amount of money that's locked up. So we don't want to have to create lots and lots of channels to everyone we might want to pay. We want, if we can just create one big fat channel to a node that already has high connectivity, that's more useful than a channel to just an isolated node. So there are directories. 1ml.com is a pretty good one where you can see which nodes have a lot of channels connected to them, and you can sort them by how recently they got new channels. Yeah.
If you open a channel with one of these nodes, are you the only one providing funds to that channel, or do they provide some funds in your direction?
The node who opens the channel is the one who puts money on the line.
So what would happen if you just wanted to be paid through Lightning? How would you achieve that if you have no connections to get in?
So you would have to convince someone to open a channel to you. Yeah, I mean, we'll get to that in a little bit. But basically, the funds are going to be tied up, so you have to choose wisely.
Sorry?
Yeah.
So within thought, let's say I'm paying for some reason to this node. Can they later function as routing nodes to me?
Sure.
Yeah.
What do you mean with balance channels? I mean, you don't have this information.
Oh, yeah, that's a good point. Ideally, you want a channel that can support payments going both ways. Right now, the only information you have when you see a channel is the capacity, which is how much it can handle. But you don't know if all the money is already on one side of the channel or the other. So, I mean, that's still a problem that isn't solved.
Well, I mean, I think it's designed, right?
Well, it's designed for privacy because if you can see how much, if you can see like the changing balance on each side of the channel, then you can see who's paying whom, and that's not very good. So we're trying to do the best, or I mean, nodes are trying to do the best they can with limited information, and I mean, L&D has a function called Autopilot where it can automatically open channels to different nodes for a new node. And Renee, I know you've written some critiques on Autopilot. So Autopilot right now is not recommended for mainnet, but it's good to understand what Autopilot is trying to achieve. So we know what the goals are in creating new channels. Okay, so the way Autopilot works is that it opens channels to nodes. The user can specify the maximum number of channels it wants and the fraction of funds to commit. And then Autopilot will select a random set of nodes to connect to. And the probability of connecting a node will be weighted according to a power law distribution. The probability will be weighted proportional to the number of channels that a node already has, according to a power law distribution. So nodes that already have a lot of channels have a higher probability of getting more channels open to them. And I mean, it will ultimately result in a lot of hubs, a lot of nodes with lots of connections. If everyone were to use Autopilot, we would end up with a scale-free network. I guess the hub and spoke model has gotten a bit of a bad reputation because people think it means centralization where there are like critical points of failure. But most social networks tend to be scale-free networks. Nodes will cluster around superconnectors, and this makes communication more efficient between nodes. And it, as long as there are many superconnectors, then there's lower risk of a single point of failure. And the network is still relatively decentralized, even though there are a few superconnectors. I mean, there are a lot of superconnectors. So the Autopilot only takes into account how many channels, or the nodes with existing channels. But there are a lot of other considerations that a node maybe can't take into account, or doesn't currently take into account, that should be a factor when choosing whom to open a channel to. As Renee mentioned, channel balance. Even though a channel might have large capacity, the capacity might all be on one side, which means it can only handle payments going in one direction. Reliability and uptime is also currently not recorded, so you can't tell how often a node goes offline. Then there's also like path diversity and redundancy. You don't want to be wholly dependent on a single node to do your routing for you. So you want to make sure that there are alternative routes if one of your channels goes down. And also, ultimately, choosing a node to open a channel to is going to be a independent and personal decision, because most people are going to primarily shop at a few different stores over and over again, so they would want as few hops as possible to get to their favorite destinations. And all these factors here are optimizing for outgoing transactions or outbound channels that you create yourself. We know how to send money elsewhere, but if we're operating an app or a store, we want money to get to us. We want people to create channels to us so that we can receive future money. So, as we mentioned previously, a open channel or someone opening a channel to you is basically is a smart contract. It represents a commitment, and it means that both parties are going to commit to operating the channel. Creating a channel with a flaky node is going to cause routing failures and payment delays, and it's a bad experience for the funder of the channel. So it can be tricky for a new user to convince other people to open channels to them. I mean, one solution is to be a good routing node, but that's kind of a chicken and egg problem, because in order to get a lot of, or in order to be a good routing node, you need a lot of incoming channels, and you can't get a lot of incoming channels until you already have a lot of channels. So another strategy is to just build a store that people like and force them to have to create channels to you in order to pay you. And, I mean, that's kind of suboptimal, but you can also just pay for the channel yourself. Since we're all going to be using Lightning for everything anyway, we can just create a channel, put some funds in it, and start spending money at other places that take Lightning payments. And if we have a funded channel and push some of it out, then that means we now have incoming capacity. A lot of new users actually would create channels and then fund the channel and inadvertently also push some amount to their counterparty because they didn't know that that's actually a commitment to spend the money. So the other two options are, well, one is to exchange on-chain Bitcoin for Lightning payments. Zigzag.io is an example of such an exchange. They let you buy Bitcoin on the exchange, and the exchange then opens a channel to your node and pushes the funds to you. So you're basically paying on-chain for off-chain or Lightning Bitcoin. And you can also do it the other way around. Yes?
For reference, that you guys build Zigzag or
Oh, okay, cool. I don't need to, well, if you have questions about it, you can ask them. All right. I mean, yeah, so the one benefit of buying Bitcoin from an exchange and getting Lightning in return is that you're now connected to a hub. If a lot of people do this, then you are automatically connected indirectly to a lot of different Lightning users. But you know, trusted third parties are security holes. There are also non-custodial swaps, because in the case of Zigzag or an exchange, the exchange is in charge of sending the funds to you and taking your payments. We can also do atomic swaps. You can use, you can create an invoice, and once the create an on-chain time lock payment that contains the hash of the invoice preimage, and then when that invoice gets paid by someone else, then you've basically done an atomic swap, and then there's no trusted exchange involved. And Alex built submarine swaps, which is one way to do it. And sparkswap.com is another exchange that matches up different people who want to perform atomic swaps on different chains. In both these cases, you still do have a central party, but the job of the central party here is to match up buyers and sellers, and also create inbound channels for so that the payment can be sent through. Okay, so now we have some ideas about how to get inbound channels. We want to maintain channel liquidity so that payments can consistently be routed to us or through us. So there are a number of reasons why a payment might fail. Sometimes you can't find a route at all because a new user just doesn't have enough channels to well-connected nodes. Sometimes a payment is too large. Well, right now, the payment size on Lightning is limited on mainnet. So some large transactions right now are better off on chain. And Lightning, as a Lightning node operator, large transactions are not convenient because a large transaction getting pushed through would suddenly take away a lot or imbalance the channel. And then there's also the problem with zombie nodes. So sometimes people, like as we saw early on, sometimes people make channels, and then the other person, or then one participant in the channel goes offline, and this information isn't relayed correctly. So payments generally fail if the sender has not enough information. And there's very limited information that gets shared over the Lightning Network through regular gossip. There are channel announcement messages that announce new public channels. And then there are updates for fees and the time lock delta or expiries. Not all channels are public, and there's basically a flag you can set when creating a channel. Some nodes won't accept public channels because they don't want to, or they can't commit to operating the channel. Because once a channel is public, it means you're willing to route payments for other people, and then anyone can start using your channel. So. Yeah, so not all channels need to be public. And then for most users that are simply doing payments or occasionally receiving payments, they don't need to create public channels. And it's right now, I think on channels are private unless announced. Well, many users, including myself, like making public channels because then we can, see ourselves on Lightning Explorers, and other people connect to us, and then I can show my mom that I'm cool and lots of people want to make channels to me. But then if I disappear because I have a flaky connection, then that's really bad, and it's basically false advertising on my part to have to make myself public and accept connections, and then disappear. So I'll invoke Adam Smith here on the idea of division of labor. There's going to be different channels, different nodes are going to be better at different things. Not all Lightning users will need to be routing nodes, and not all Lightning users will it'd be expected to stay online and maintain channels all the time. Okay. So there ultimately in the network there will probably be a number of nodes that are there just for routing. They're earning money from fees, so they're incentivized to stay online and maintain balanced channels. As a Lightning user, even if you don't have public channels, you can have private channels and then provide people who want to pay you with routing hints in your invoice. So when you create an invoice in Lightning, you can add a field that indicates what the intermediate nodes are, that indicate what some intermediate nodes are. So the payer can find a path to you even if you don't have any public channels available. Yeah, this way, if more people make their channels private, then the information that nodes have will be more reliable. So ultimately, want to be a good node, and if you're a public channel or a public node, or if you have public channels, keep them balanced. You can set your transaction fees to, or you can set negative fees to encourage transaction flow across the channel. And also, like, shut down gracefully. If you're going to disappear for a while, close the channel with your counterparties instead of leaving them hanging. And also, you can be a good node by punishing bad nodes. You can close off channels that have been inactive for a while. Yeah.
If you've got a channel open with someone else that's kind of got a lot of funds on their side but not much on your side, is there a way you can swap that up without having to completely close the channel and just open it from your side?
You can use that. You can use that counterparty node as a route for something else. But ultimately, if you want money to go to the other side, you have to spend money on something.
I mean, just sort of adding more funds from your.
Oh, like rebalancing?
Yeah.
So at the moment, you would need to close the channel and add more funds. But in the future, there's going to be like splicing where you can resize open channels. Yeah, so it's still all a work in progress. Right now, high capacity channels are very scarce. Soon there will be multi-path transactions where you can split a payment up over many channels to distribute the payment and not be constrained by the maximum channel width. Yeah, and then in the future there will be splicing where you can resize open channels and channel factories where payment channels can be used to create more. I won't go into details about this, but other speakers know more about that than I do. And ultimately, nodes will start accumulating more information and be able to make better decisions. I think future implementations will allow nodes to track more metrics about past routing successes and failures, so they know which channels are duds and which nodes are flaky. Users will also be able to find out more about which channels were closed unilaterally, or just by one party because the other one disappeared, or which ones were mutual closes, because you can go on a block explorer and look at the closing transaction. If there was like a long timeout on the time lock on the closing transaction, then you know that it was a unilateral close. And active node management will also help to inform the Lightning developers how to create better strategies for finding paths and choosing nodes to connect to. So just to show how far we've come, this is what the Lightning network looked like in January. This is mainnet, and this is what it looks like a couple weeks ago. So we've come a long way, and hopefully in the future we'll see less of this and more of this. And that's it.
So like today, if I want to be a good node, what tools are at my disposal to know like how I'm being a bad node and how I'm being better?
You can look at your, you can see, I mean, watch your channel to see like if people are actually using your channels. I mean, if you're being a good and helpful node, you'll probably see transactions being routed through your node. And
I guess to dig like even deeper, like when you say watch your channel, you're talking about tailing logs or like what tools are available for making that compute?
so the command line tools will show you like what fees you've earned from operating your channels, so you can know if they're being used.
How likely is it that nodes will game the system and lie about their advertisement or the direction of flow within their payments, within their channel, sorry? And is there any way to detect that? Like if you don't lie about capacity?
Well, capacity can't be lied about because you can see exactly, I mean, you can see the funding transaction, so you know exactly how much is locked up.
Yeah, but you don't know like what are the off-chain channels with its counterpart.
Yeah, oh, the channel balance.
Exactly.
Yeah, I mean, right now that information isn't really being communicated at all, so it's more of a trial and error thing. You can try to push a payment through a channel, and if it doesn't work, then you know it can't handle it.
It's what I meant. Trial and error.
Yeah.
If you don't know the channel balances, like realistically, how many times you have to push a payment before you find something that does have the correct balance to actually let the payment through? Like a lot of the times you can run into channels that are being exhausted in the direction of trying to push payments.
Yeah. I mean, information is updated in real time, so I mean, nodes might have stale information.
Is that information that, like, as a developer, I'm facing a node and have a payment fail? Does most node software like take account of that internally, or is that something you kind of have to explicitly, as like a developer on top of a node, say, okay, that didn't work, let's not try that node ever again?
I think with LND, you get one chance, or a bad node gets one chance to have a do-over. I'm not 100% sure of that. And then after that, it goes on a blacklist.
So we just temporarily disable channel for that phenotype and then try another one. We don't blacklist nodes, it's channels that are failing. And since this is very temporary information, we also just disable temporarily instead of discarding.
Did I understand correctly? This blacklisting LLD is like forever. Like if the node doesn't work at some point in time, and it becomes a zombie node LLD, another LLD node, you just blacklist this node and never use this and pass this company again, because I mean, this would be kind of bad.